Hello again. We continue with our previous lecture in a way that we discussed descriptive statistics, and now we are going to discuss about some graphical tools which can be utilized to explore patterns or behavior in the data. So as I'm keep repeating, we should first start with graphical measures to understand data. Again, the same quotation, torture numbers, and they will confess to anything, which is the main goal of, say, this course. In statistics, that's what we do. Graphical tools for data illustration. There are many, by the way, there are many graphical methods which can be utilized to explore data. But I will target some very basic, some very known and common methods which one should be familiar with if one is dealing with data analysis. Most complicated methods can come across, of course, but one should start with the basic ones, the easiest ones. So the dot plot is the most basic and one of the classic graphical method. It says that a graphic method or a graph, the dot plot actually, is used to display the original data. And how do we do that? Well, draw a number line and put a dot on it for each observation. So you draw a number line if you have a data for sequence ranging from 2 to 20. So you draw a number line 2, 3, 4, 5, 6, 7, 8 up to 20. And then you start somehow stacking the dots with the observation you have in the data. So if you have, for instance, in this example, if I have 4 and then I put a dot over 4, and then I notice there is a number 10, so I put a dot at 10. Then I notice there is a dot at 6. There is a number 16 in my data, so I put a dot at 16. Then I notice there is a position, there is a data or data point actually in my sequence which is 6. So I come across and come back and then put a dot at 6. If I notice again a 4 number in my data, I put another dot at 4, and then I keep doing this until I am done. And then you will see that all of those stacked dots actually gives you a pattern of the data. So here in this data, or in this example, you see that number 8 occurs very often in this particular sequence. It means 8 is the mod of the data, very obvious. If I want you to draw a somehow line over that, if possible, I can see whether this data is somehow positively skewed or negatively skewed or properly somehow deviated across mean or not. What is the dispersion of the data? Things of that sort we can immediately notice. Well, not always actually, of course, but most of the time we can immediately notice about the data through this particular plot. Histogram is another very famous tool for evaluating the distribution or density of the data, how dense the distribution is. So this graph will display the shape of a numeric data by grouping it in intervals. So if you notice this graph, so what I would suggest you to do is start connecting those tops with a small line or a thin line actually, the top of those bars. So and by the good idea is to start with the middle point. So you take a middle point of each bar and make a dot over here, which is a good strategy, which could be a good strategy actually. So make a dot in the middle of each bar. And then once you're done with making a dot, start connecting them. So this curve, this line will give you a pattern of the data. And we will learn in previous lectures, in the next lectures. We have learned actually a bit, but in more detail, we will learn about normal distribution and how the density or the distribution of data can be studied. So we move on, and then, well, another plot is a stem and leaf plot, also very popular and one of the classic plots, classic graphical tools as well. It's quite similar to a dot plot, but here data are grouped according to their leading digits, and the last digit is used as a plotting symbol. So what we do, we make a plot, we call stem and leaf. Well, so stem are designed, you know what is a stem in a tree, right? And every stem has lots of leaves, right? So the leading digits, we make those leading digits as a stem of the data, and then we use the last digit of that particular leading or each pair of the digit as a leaf of that data. So for instance, if you have a data like that, 73 is 42, 67, 78, 99, 84, 91, 82, 86, and 94. So the leading digits are 7, 4, 6, 9, 8. These are the leading digits. 7, 4, 5, 6, 7, 8, 9. I have put him in ascending order. And then in the leaves, you start connecting the dots, the nodes. So 4, because the one of the observation was 42, so it's like 2 comes over here with 4. Well, I said 5 here because I wanted to have a sequence, but I noticed that there is no 5, or there is nothing in 50s in this data. With 6, I can see 67. With 7, I can see 73 and 78. So I put a small gap between 3 and 8, just to recognize that these are the two different digits actually. With 8, I can see 82, 84, and 86. With 9, I can see 91, 94, and 99. So again, we plot them, and in the end we make a curve to see do we see anything here or not. Sometimes it's obvious, sometimes it's not. So if it's not obvious, then we move on immediately to some other options. But if it's obvious, then we use that observation for our next strategy for modeling actually. Bar plots are also very important, and you might have seen this in many social science research papers and other in similar areas. It is a chart that represents grouped data with rectangular bars with lengths proportional to the values that they represent. So like human losses of World War II by country. I downloaded this graph from Wikipedia, and it's a nice graph with 2 bars at the same time for each variable. So there are many variables like Soviet Union, China, Germany, Poland, Indonesia, Japan, so on up to Netherlands and other. So I have all those variables, and each variable has 2 categories. Say losses in millions and losses as percentage of country population. So I have 2 colors here. The red shows losses in millions, and blue shows the percentage of country population, how big the percentage was in terms of their losses. And I can see here the length of those bars actually represent me how big, or in numbers, how big the losses are actually. And you see that Soviet Union was, of course, as we know from history, lost a lot in millions, in terms of millions, and also in terms of population of their country. It's a big country, that's why, since the loss was huge, they suffered in terms of their population as well. If you notice here, Poland is not a big country, and they lost not many millions in the Second World War, but in terms of population, they lost a huge chunk of population because it's not a big country. Similarly, Lithuania, you noticed, it's a very, very small country, like 1 or maybe less than 1 million or less than half million actually died, or human who lost this in this war from this country. But since it was a very, very small country at that time, so the proportion of that loss was huge for them with respect to the total population of the country. So that's how we somehow describe data in terms of these plots. Very useful in many ways. We move on, we come across with the box plot. Sometimes we call them box and whisker plot, because if you notice in this small graph, the red portion is a box, and this line over there is the whisker, the cat whisker, so to say. And box plot is a very convenient way of graphically depicting groups of numerical data through their quartiles. So just recall quartiles we learned in the previous lecture. So we are going to use them here to make this plot. The box plot represents 5 sample statistics. So it's a very, very informative graph. It accommodates 5 sample statistics to finish this graph, to complete this graph. The minimum value of the data, the lowest quartile, which is Q1, the median, which is Q2, the upper quartile, which is Q3, and the maximum, which is the highest value in the data. So once you have those 5 statistics of any data, you can easily plot box and whiskers plot for that data. Outliers may be plotted as individual point if there are outliers in the data. So we have here the minimum value, which is 4 for any example, for any data. 12 almost is the maximum value. And then we calculate the lower quartile, which lies somewhere between 6, well, after 6 actually. Median lies somewhere near 8. The upper quartile, which is Q3, lies between 8 and 10, and somewhere closer to 10. And then once you have done with those points, just combine them with a line. And the box actually, which is the interquartile range. Remember what is the interquartile range? The interquartile range was the difference between Q3 and Q1, means the upper quartile and Q1, which is the lower quartile. So that's why this box ranges from Q1 to Q3. And the rest, well, the to minimum and to maximum are the whiskers, right? Sometimes we draw a curve within this box to see the behavior of the data, the pattern of the data. So it's a very important graph, and we will be working on those graphs a lot in our SPSS sessions, in our assignment sessions, and also in the project to learn about data. Finally, I have another very informative plot, which is pie chart. It is a circular statistical graph which is divided into slices to illustrate numerical portions. How many, or say the total proportion of particular data, if I divide them in different groups, how many of the total proportion each group has actually, and that can be easily depicted through pie chart. Pie charts are very popular actually in terms of in evaluating population actually. Population within groups, or population describing group of different variants within population. Election results are very much or very most popularly actually represented or showed in terms of pie charts. And you see here education policies. I have a data here from internet. So Liberal Democrats, well, it's a Swedish government, well, it's the UK government, sorry. It's a UK government, and according to UK, Liberal Democrats, they say 23% they are going to support educational policies. UKIP, another political party, they say 20% we will support that policy. Green Party 15%, and other parties, not the bigger ones, they support, their chunk is 5% in terms of supporting this education policy. So it's a very informative graph, one graph, and you can see how opinions are changing within in terms of that particular policy within each political parties, and which party has more weightage over that and which party has less weightage over that. So one particular graph, and it shows a very well, enormous amount of information actually. So that's why graphical plots are very useful in many ways. So we should first start with graphical plots and then move on for statistical modeling. So I finish my this part of lecture here, and we will be learning more about modeling stuff from now on. So I suggest you to please go through all the lectures which I have uploaded or delivered earlier. And if you have any question or suggestion, please mark them down. When we meet, we will discuss them in detail. Thank you very much.